Let's do a couple more examples of solving quadratic equations using the quadratic formula. So just as a reminder, quadratic equations need to be of the form ax squared plus bx plus c equals 0 in order to use the quadratic formula. And then, ideally, it would be great if a were positive. So in these examples, what we're going to do is make sure we get equals 0 on one side, but also try to get the x squared term to be positive. So that's our goal. We're going to move terms to one side of the equation. Ideally with x squared being positive. It's not necessary, but it makes things a lot easier. All right, so let's try it with this problem. So I have x squared equals negative 2x minus 3. I cannot use the quadratic formula in this form because it doesn't equal 0. So what I need to do is add 2x and add 3 to both sides. And I picked that because I wanted to keep the x squared on the other side to make sure it stayed positive. The other option would have been subtracting x squared to this side, but then everything's negative, I gotta deal with that. It's a little messy. Our quadratic formula, let's make sure we have that. Getting practice, eventually getting memorized. So it's negative b plus or minus the square root of b squared minus 4ac all over 2a. To use this formula, we need to identify our a, b, and c, which are the coefficients on x squared, x, and then the constant term, respectively. So here my a is 1, b is 2, and c is 3. So now let's plug them in. I get negative b would be negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 3. All over 2 times 1. Now, this one's not that difficult to do in your head, but I know some of you are loving that we can use our calculators in this section. So when we're doing these on our calculator, just put what's inside the square root in there. So that'd be 2 squared minus 4 times 1 times 3 equals. All right, so I'm just doing what's inside that square root. All right, so let's write that out. I got negative 2 plus or minus the square root of negative 8, and then 2 times 1 is just 2. Couple things. One is we don't want to cancel or reduce. These 2's don't cross out. We need to use heart simplification, meaning we need a factor out here in front of the square root if we're going to cancel. It has to be in both places. And also you can't cancel a 2 with anything inside that square root. So we have to combine square roots with other square roots or numbers with numbers. Doesn't work that way. All right, so where we're at right now though is that this is not a real number. Now, eventually we are going to learn about imaginary numbers, but for now, we're just done. So this is not a real number. Yeah, I think that's how our homework is going to have us write it too. So we'll just write not a real number. In the next section though, just be prepared, we're going to learn how to simplify when there is a negative under a square root. All right, let's do another example. Again, these are different just because we have to get equals 0. It doesn't work to use the quadratic formula when it's equals 1. It also doesn't work to use the quadratic formula when it's in a factored form like this. We need to multiply all that out. Now, there are a few different ways that we can go about this. That you can multiply the 2 first, as long as it's just in one of the parentheses. You can multiply the 2 after you FOIL. I'm going to multiply the 2 just in this first parenthesis. So I get 2x plus 2 times 3x minus 1, and we'll deal with that equals 1 after we multiply this out. So using FOIL, or you can use the box method, we would get 6x squared minus 2x plus 6x minus 2 equals 1. And now that's when I'm going to start subtracting 1 from both sides because I definitely want equals 0. I can also combine these like terms in the middle. So I get 6x squared plus 4x minus 3 equals 0. And it's that equals 0 that we need to use the quadratic formula. So now let's identify our A, B, and C. A is 6, B is 4, and make sure you view C as -3, not +3. If it helps you, write out the quadratic formula again. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Especially as you're getting better and better at it, it's going to help to write it more and more. Opposite of b is going to be -4 plus or minus the square root. And I didn't do it in the previous problem, but one thing I like to do is just to square b in my head because I know my perfect squares. 4 squared is 16 minus 4 times 6 times -3 all over 2 times 6. All right, so it's okay to use a calculator, but for what's under the square root only in the first step. So I'm going to do either 4 squared or 16 minus 4 times 6 times 3, make it negative, equals, and I get 88. And then 2 times 6 is 12 on the bottom. This is positive, so it is a real number. So now we need to simplify the square root. I can't cancel the 4 and the 12 or reduce that until I have perfect squares out of that 88. So now we need to figure out what perfect square goes into 88. Good thing we know our perfect squares, right? If in doubt, you can always make a list of, okay, let me make a list of my perfect squares. They're 4, 9, 16, 25. And it keeps going, but most of the time it's one of those that we're looking for. And in this case, it's just 4 that goes into 88, out of this small list at least. So 88, the square root of 88 is the same as the square root of 4 times the square root of 22. Because 4 times 22 is 88. And I'm purposely factoring out a 4 because it's a perfect square. So now this is -4 plus or minus the square root of 4 is 2. And then the 22, I can't simplify that square root. It just stays a square root because there's nothing else to simplify, over 12. And now, in order to simplify this further, we get to draw a little heart and look for what's in common between the 3 constant coefficients. The ones that aren't, they're all constants. The ones that aren't a square root. And in this case, the only thing they all 3 have in common is a 2. So I'm going to divide all 3 by 2. So that gives me -2 plus or minus the square root of 22 over 6. You can write the 1 in front of that square root if that helps you. I did do 2 divided by 2, but multiplying by 1 doesn't change that square root.